Welcome to Relax Story, a place where gentle stories help you leave behind the noise of the day and slowly drift into a peaceful sleep. Each soft, soothing narration is designed to relax your mind, release tension, and guide you to a deeper sense of calm within. If you enjoy the experience, don't forget to like and subscribe to stay with Relax Story every night, and feel free to leave a comment to share your thoughts or suggest a story you'd love to hear. Now close your eyes, take a deep breath, and let Relax Story guide you into a restful deep sleep. In the open oceans, where the water column stretches from hundreds to thousands of meters, light begins to weaken within the very first layers, then slowly dissolves entirely as depth increases, leaving behind a vast expanse where color no longer exists, and every form becomes only a shadow drifting in silence. There, sound becomes the only medium capable of enduring. For water carries acoustic waves many times faster than air, allowing even the faintest vibrations to travel across kilometers with almost no loss, shaping a world without landmarks, without direction, where distance is no longer measured by light but by motion, where everything seems to drift in a state approaching biological weightlessness. So still that silence itself begins to feel like a presence, and within that stillness, something begins to form, not as light, not as image, but as rhythm. The being that generates this rhythm exceeds every familiar boundary of life, a body whose mass often reaches from 100 to 150 tons, sometimes more, extending like a vast biological structure moving slowly through the deep water column. Within it, a heart weighing nearly 200 kilograms, large enough to be compared to a small vehicle, contracts at a pace of only a few beats per minute when submerged, then gradually accelerates as the body approaches the surface, each contraction pushing out more than 200 liters of blood, a volume sufficient to fill the space of many smaller bodies. One beat, then another. Not hurried, not forceful in appearance, yet powerful enough to send a disturbance outward beyond the limits of its own form. These disturbances do not remain confined to tissue and vessels, but continue outward into the surrounding water, transforming into minute yet stable pressure variations, traveling through the column as a continuous acoustic field, subtle enough to dissolve into silence, yet strong enough to persist across distances unreachable by light. There, the activity of a biological organ is no longer merely internal, but becomes a physical phenomenon capable of propagation, a quiet underlying pulse existing within the ocean, where even the smallest motion contributes to shaping a space far greater than itself. From a single body, the influence extends beyond physical boundaries, as the heartbeat no longer belongs solely to the organism but merges with the surrounding environment. As a biological process transforms into a component of the ocean itself, as the boundary between body and space begins to blur, existence is no longer isolated but interwoven into a system where an individual participates in larger chains of interaction, linked to nutrient flows, to trophic structures, to the slow yet persistent movements of an entire ecosystem. At such a scale, the question begins to change. Is a whale merely a creature, or a convergence point where multiple processes meet, an unseen node within the vast network of the ocean? If that heartbeat were to cease, would those invisible connections remain? Would nutrient currents continue to flow? Would the quiet equilibrium retain its form? The answer does not appear, the rhythm continues. And from that slow, steady pulse, another journey begins to take shape, not forward, but turning silently backward across tens of millions of years toward a distant moment when a creature first left the familiar ground and stepped into the water, where the limits of life began to be rewritten from the beginning. Around 50 million years ago, as Earth entered the Eocene, another world unfolded, warmer than the present, where the coastal regions of the ancient Tethys Sea stretched across what is now Pakistan and India, where land had not yet fractured into its modern forms, where rivers emptied into warm marshlands, where shallow waters reflected a sky that rarely knew cold, and where life expanded in ways both abundant and fiercely competitive. On land, predators competed endlessly for every source of food, every stretch of territory, every chance at survival, while just beneath the surface, another world existed in parallel, richer, more abundant, less contested, where fish and aquatic organisms moved according to rules the land could not impose. Within that space where two environments touched, where the boundary between land and water was never fixed but shifted with the tides, a movement began to emerge, so slow it was nearly imperceptible, yet sufficient to alter everything that would follow. The creature that carried this movement was known as Pachycetus, a mammal belonging to the even-toed ungulates, measuring roughly 1 to 2 meters in length, bearing the familiar form of a terrestrial predator, reminiscent of a wolf or a hyena, with long, powerful limbs designed for running across land, for pursuing prey, for surviving in an environment where speed and endurance determined all. Everything in its body declared that it belonged to the land, from skeletal structure to movement, from posture to the way it surveyed its surroundings. And yet, deep within the skull, a subtle detail remained, a structure of the ear with a distinctive form found only in modern marine mammals, a quiet signal that the history of the ocean had begun to appear before the body itself had changed, a creature still standing on land, yet already carrying within it another direction. Pachycetus lived along rivers and shallow lakes, where the boundary between land and water blurred, where each step might touch ground and then water, where prey did not only run but swam. Its food came from fish and small aquatic organisms, abundant sources of energy no longer easily available on land. Its body was not yet designed for swimming, without fins, without insulating fat, without any defining traits of an oceanic life, and so its movement in water remained awkward, perhaps wading in shallow zones, stepping slowly, or lunging suddenly to seize prey before retreating quickly back to shore. At that time, water was not a home, not a primary world, but only an extension, a temporary opportunity, a resource not yet fully claimed. Pressure from the land grew clearer as predator numbers increased, as food sources fragmented, as each hunt became more difficult, more costly, more uncertain. In contrast, water offered an ecosystem that seemed almost boundless, where fish moved in schools, where competitors were fewer, where competition had not yet reached saturation. This contrast did not create an immediate transformation, but a tendency, a pattern of repetition, a behavior that appeared, then gradually became familiar. Pachycetus entered the water more often, not to escape but to seek, not because it was forced away, but because it was drawn in. time beneath the surface lengthened slightly. The distance between returns to shore expanded, and those small steps accumulated into a direction that could no longer be reversed. The land was not abandoned, but the water was chosen. Pakicetus existed at a point of transition, where two worlds met within a single body, where form still belonged to the past, yet function had begun to lean toward the future. Its structure remained that of a terrestrial animal, yet its senses, particularly its auditory system, had begun to adapt to water as though the ocean called from within rather than from beyond. This was not a complete transformation, not a leap, but the beginning of a sequence that would unfold over tens of millions of years, where each generation adjusted a fraction, each change accumulated a little more, until the final result would become unrecognizable from the origin. It began with something almost insignificant, a mammal that entered the water slightly more often than before, yet the consequence did not remain within behavior, but spread across the entire direction of evolution. When such behavior ceased to be an exception and became a recurring pattern within a population, across generations it created new selective pressures, favouring those individuals better adapted to aquatic life, preserving even the smallest advantageous variations. The history of whales began there, not with a sudden appearance, but with a repetition so persistent it became destiny. No one at that time could see the outcome, but the process had already begun. From a single act, a survival tendency formed. From that tendency, body structures began to shift, slowly yet irreversibly. From those structural changes, a new form of life began to emerge, capable of existing between two environments, belonging to land yet touching water, an unstable state, yet filled with possibility. And within that state, the door opened to deeper transformations, as the body moved beyond merely entering the water and began to move toward living entirely within it. Around 49 to 47 million years ago, during the Eocene, in a region that is now Pakistan, where vast river deltas once opened into warm, shallow seas, where fresh water and salt water mingled in a state of delicate suspension. A state of suspension was also unfolding within the bodies of ancient creatures themselves, as the descendants of Pakicetus no longer stood fully upon dry land, yet had not truly become of the ocean, when each step on shore was still familiar, yet each descent into water grew easier, longer, more natural, as though an invisible force was slowly shifting the centre of their existence, from land into water, from solidity into drift, from walking into motion, and from this point forward, evolution no longer paused at altering behaviour, but began to reach deeper into structure, into bone, into joint, into the smallest movement. Ambulocetus natans emerged within that moment, a name that carried its own contradiction, a creature that could walk, yet seemed born to swim, inhabiting shallow coastal waters where riverbeds were soft and currents slow, where the surface reflected the sky, but beneath it lay another world, where it moved on four limbs still strong enough to bear its weight on land, yet no longer as long or as flexible as those of its ancestors, where the feet became broader, flatter, as though learning to push against water rather than earth, where the tail lengthened and grew more powerful, not merely to balance, but to generate force, to drive the body forward within a new medium, And when it swam, the body no longer relied on separate steps, but began to bend in rhythm, rising and falling, wave-like, a pattern of motion that would be refined tens of millions of years later in the giants of the oceans, when the entire body and tail would become a single engine of propulsion. Ambulocetus was no longer a creature that stepped into water to hunt and return to land. Its form had already begun to tell a different story. Alongside it, Indochus, smaller, quieter, carried within it a deeper trace of change, with a body no larger than a small hoofed mammal, yet with bones that are denser, heavier than usual, allowing it to sink into water more easily, no longer floating as land animals do, as though water was no longer a foreign realm, but a place to hide, a place to withdraw, a place to exist in silence, even as its ability to swim had not yet fully formed, even as its movements remained clumsy. Its prolonged presence in water was enough to alter the way its body engaged with the environment, enough to lay the first stones of a semi-aquatic life, where water was no longer an occasional choice, but part of survival, part of instinct. Changes began to accumulate, slowly, almost imperceptibly within a single lifetime, as movement shifted from reliance upon limbs alone to the coordination of the entire body, as the spine ceased to be merely a pillar for balance and became a source of thrust, as limbs still remained visible, yet their roles began to change, from running to swimming, from support to propulsion, as bone structures in certain semi-aquatic forms grew denser, heavier, allowing the body to regulate buoyancy, to remain stable beneath shallow waters, and as behavior changed, everything else followed. Water was no longer a place entered briefly, but a place for hunting, for shelter, for movement, for advantage, and as movement changed, the world itself began to change. This was the phase when the body began to be rewritten, when legs slowly lost their role as instruments of running, when the spine learned to bend and generate force, when the living environment gradually slipped away from land and leaned toward water, not in a sudden leap, but through a chain of small adjustments, behavior shifting first, the body following after, the environment slowly redefining itself, until the entire trajectory of evolution was drawn toward a different direction, where the boundary between land and water was no longer clear, where a creature could exist in both worlds, yet no longer fully belong to either. The reversal unfolded so slowly it was almost invisible, as water began merely as support, then became advantage, and finally began to shape the body itself, as Ambulocetus could still climb onto land, could still walk, yet each movement within water became more natural, more efficient, as though the body had begun to favour another environment, another path, another future, a creature no longer simply using water, it was being shaped by it. After this phase, the bodies of early whale ancestors swam more effectively. Limbs gradually lost their original function, while the tail, body, and spine became the centre of motion, changes accumulating, preparing for a greater transition when land would slowly be left behind, when forms like Basilosaurus would emerge, no longer returning to shore, no longer hesitating between two worlds, and when the journey away from land, once begun, could no longer be reversed. Around 35 to 40 million years ago, toward the end of the Eocene, when continents still bore shapes unfamiliar to the present, and ancient oceans still carried the traces of a vast Tethys sea once linking distant lands, a silent yet complete transition unfolded. No longer tentative steps between two worlds, no longer creatures retaining the ability to return to shore, but evolutionary lines that had fully released the land, drifting deeper into water as an irreversible path, while marine ecosystems themselves began to restructure as new large predators appeared, filling vacant roles within the food chain, forming a stage where perfection was no longer optional but required. Within that expanse, a form emerged, stretching 15 to 17 meters in length, its body extended like a continuous motion through water, neither fish nor serpent, but something suspended between memory and the future of mammals, Basilosaurus, a representative of the Archaeoceti, bearing within it the traces of terrestrial ancestry, yet transformed to the point of near unrecognition, its body elongated like a colossal sea serpent, moving through ancient waters, no longer carrying any sign of a creature that once walked upon land, every contour, every structure directed toward a single purpose, existence within the ocean. That body was not only long but fluid. The spine extended and developed in a way that allowed continuous wave-like motion, each undulation driving the body forward, minimizing resistance, creating a movement as seamless as the medium surrounding it. Behind it, a powerful tail, not sweeping side to side like fish, but striking up and down along a vertical axis, a pattern that would later define modern whales, each stroke a thrust, each thrust a step forward through the three-dimensional space of the ocean. At the front, four limbs transformed into fin-like structures, no longer bearing weight upon land, serving only to guide movement in water, while the hind limb had shrunk into small, nearly useless remnants, not participating in motion, existing only as a biological memory, a silent trace of the past. Its entire life unfolded beneath the surface, no longer returning to land, no longer divided between environments. Hunting took place in deeper realms where light faded, where large fish and other marine animals became prey. At times, even smaller whales fell within its reach. Its immense size combined with speed and bite force, forming a predator at the apex, not through ferocity, but through the absence of equals, a dominance that required no declaration. The difference from earlier semi-aquatic ancestors became unmistakable as the ability to return to land vanished entirely. The body no longer supported terrestrial movement. The entire life cycle unfolded within water, from survival to reproduction, from hunting to rest, respiration dependent upon surfacing for air, locomotion optimized for swimming, every organ, every structure, every movement serving a single purpose, no excess, no alternative, only absolute specialization, an existence redefined from its foundation. The emergence of Basilosaurus marked a decisive boundary, not merely a step, but a line, where a lineage of mammals separated from its terrestrial origin and became part of the marine ecosystem, no longer seen as creatures that had come from land, but as intrinsic elements of the ocean. Once that boundary was crossed, there was no return, no intermediate state, no existence between worlds. From a broader perspective, this was the moment when evolution crossed the threshold of irreversibility, where the transition from a semi-aquatic organism to a fully marine one was not merely a change in form, but the complete abandonment of one environment in permanent bond with another. No duality, no choice, only a single direction. There was no return. From that foundation, new paths began to open, as whales fully adapted to the ocean. Evolution no longer focused on basic adaptation, but on divergence, forming distinct survival strategies. Some lineages moving toward filtering nourishment from vast bodies of water, others continuing the path of active predation. Each branch a different solution to the same problem of existence, preparing for the deep division between toothed whales and baleen whales. Different forms of being, yet all rooted in a moment when every path back had disappeared. Some 34 million years ago, as Earth crossed the colder threshold between the late Eocene and the early Oligocene, the ancient whales were no longer newcomers to the sea. Their bodies already belonged to the water. Their breath had bound itself to the surface. Their movement had merged with the silent buoyancy of the ocean. And yet, once living in water was no longer the greatest challenge. The ocean began to ask a deeper, quieter, and far more unforgiving question. Not simply how to live here, but how to live within it. For the ocean is not a single, uniform space. There are regions where the surface glows with plankton, where small drifting lives gather in slow-moving abundance. There are places where fish and squid flash like silver shadows, swift, elusive, gone before they can be touched. There are vast open waters where sheer size and the careful use of energy become an advantage. And there are the deep, dark layers where light fades into nothing, where sight no longer suffices, where sound becomes the only way to perceive the world. From the same marine foundation, whales began to diverge along different paths, as if the ocean had no desire to shape a single form, but instead sought to test many ways of existing within the same boundless realm. From that divergence, the lineage of modern whales slowly emerged in two great branches. One became the Mysticeti, the baleen whales. The other became the Odontoceti, the toothed whales. At first glance, the difference seems to rest in the mouth, one bearing baleen, the other retaining true teeth. But beneath that surface lies a far deeper division, a division of feeding, of energy, of perception, of how each enters the layered ecologies of the sea. From this moment on, the ocean no longer sustained a single kind of whale. It unfolded into two nearly opposing languages of survival. In the first branch, the baleen whales did not hunt by seizing individual prey. Instead, they developed rows of keratin plates suspended from the upper jaw, like a vast living filter stretched between water and life. When they open their mouths and take in immense volumes of water, the water is pressed outward, while krill, plankton, zooplankton, and small schooling fish remain trapped within delicate fringes. A single slow movement gathers countless fragile organisms. A single filtering act transforms thin densities of drifting life into energy, for bodies so immense they verge on the unimaginable. This branch does not chase prey. It learns to consume abundance itself. And here, a quiet paradox of evolution emerges. One lineage turns toward the smallest forms of life, creatures that nearly dissolve into water, fragments so small they might escape the eye entirely, and from them builds the largest bodies ever to exist on this planet. The small sustains the colossal. Fragility becomes mass. Through baleen, the ocean is filtered into flesh, into fat, into motion, into migrations that stretch across distant seas. In the second branch, the toothed whales follow another path. Here are the sperm whales, the dolphins, the orcas, the beaked whales, the belugas, the narwhals, creatures that retain their teeth to hunt fish, squid, and other marine animals. But teeth are only part of the story. What turns many of them into extraordinary hunters is their ability to use sound to map the world. They release sequences of sharp clicks, sending waves through the water, striking objects, returning as echoes, and from those echoes constructing an invisible image of their surroundings. In dark water, where light dissolves and form fades into shadow, sound becomes a second sight. If the baleen whales gather abundance, the toothed whales decipher secrets. They search, pursue, ambush, coordinate, respond to prey that moves, that hides, that vanishes. Such a way of life demands a flexible nervous system, refined acoustic perception, and in many species, more complex social behavior. For active hunting is not only a matter of strength, but of understanding space before the prey is gone. Some, like the orcas, rise to the apex, exerting control over fish, squid, and even larger marine animals within a vast ecological network. From a shared evolutionary history, two strategies take shape, like two different breaths of the sea. One draws upon dense, small, seasonally shifting food sources suited to immense bodies, long migrations, and the storage of energy. The other depends on orientation, reaction speed, spatial memory, and at times coordinated social behavior, suited to complex environments where prey can flee, conceal itself, or disappear into darkness. They do not occupy the same place in the same way. They divide the ocean into layers of roles, one for the quiet abundance of the small, another for prey that is faster, larger, and far more elusive. This separation does not arise from the will of any single creature. It emerges from food, from currents, from depth, from light, from sound, from survival repeated across millions of generations. Over time, whales cease to be a single drifting group within the sea. They become a system of multiple strategies. One filters the ocean, the other listens to it. And after that branching moment, each path continues to draw the whale body further into its own direction. Jaws, teeth, baleen, senses, muscles, movement, energy use, all are gradually reshaped according to their way of life. The story no longer rests on the fact that whales live in water. It moves into something far stranger, how far a body can be redesigned to endure cold, to conserve energy, to descend into darkness, and to cross vast oceans as though the sea itself has become its second form. The ocean unfolds as a space without boundary, where light is swallowed within a few hundred meters, where temperature falls toward freezing as depth increases, where pressure rises layer upon invisible layer, pressing against every biological structure, where no free oxygen exists to breathe, only brief moments at the surface. In such an environment, life does not merely persist, it endures. It holds warmth against a cold that seeps into every cell. It sustains energy across journeys that stretch for thousands of kilometers without pause. It continues to function when oxygen is cut off during long, deep dives. A creature entering this world cannot survive by adjusting only a few outer traits, for every small flaw becomes a threat magnified. Adaptation, in its ordinary sense, is no longer enough. The body begins to change in form as though water itself redraws its structure through motion, lengthening, smoothing, erasing every unnecessary edge until only a tapered shape remains, like a drop moving through its own element. No protrusions to resist, no forms to disrupt the flow, only a body that glides with minimal drag. The result is not merely speed, but efficiency, the ability to travel farther on the same energy, to cross vast oceans without being worn down by the very environment it inhabits. When resistance fades, energy remains. When energy remains, distance ceases to be a limit. Beneath the skin, another system takes hold, dense and silent, yet decisive for survival in cold water, a thick layer of blubber measured in centimetres, sometimes tens of centimetres in the largest individuals, encasing the body like a garment never removed. It preserves heat, preventing the ocean's cold from penetrating inward, while storing energy as a living reserve, sustaining long migrations, enduring periods of scarcity, carrying the body through journeys with no certainty ahead. It also allows subtle control over buoyancy, rising or sinking with precision, adjusting position within the water column without excess effort. A single tissue performing the work of an entire system, not only preserving warmth, but sustaining life. Within, blood and muscle tell another story, one where oxygen becomes a resource to be stored, distributed, and used with near-perfect precision. Blood volume increases, hemoglobin concentration rises. Each breath carries more oxygen than in land animals of similar size. Muscles are rich in myoglobin, holding oxygen where it is needed most, allowing activity to continue even when the lungs can no longer supply it. Oxygen is not simply inhaled, it is carried, stored, spent in silence, and so the body can descend hundreds, even thousands of meters below the surface, where light no longer exists, where time stretches with each slowing heartbeat. When oxygen disappears from the outside, it's already present within. The nervous system and physiological responses complete this transformation, allowing the body not only to endure pressure, but to function steadily where many structures would fail. As the whale dives, the heart slows, deeper, quieter. Blood is redirected toward the brain and heart, while less critical organs reduce their demand for oxygen. Everything adjusts not for a moment of survival, but to extend time beneath the surface to its furthest limit. The body does not merely change its form, it changes the way it operates. This process does not occur in a sudden leap, but unfolds over millions of years, beginning with small adjustments as a land creature enters the water, continuing through gradual changes across every biological system, until the boundary between adaptation and complete reconstruction disappears. In the end, there is no longer a land body modified for water. There remains only a biological system designed entirely for the ocean, where every trait exists because it must, where every part serves a single purpose. These transformations open possibilities that did not exist before, allowing descent into lightless depths, movement across immense distances without interruption, survival in extreme cold without constant reliance on food, conscious control over breath, communication across vast stretches of ocean, and the formation of complex social structures that extend beyond simple instinct. When the biological foundation reaches its optimal state, new capabilities emerge as inevitable consequences. At some point, the boundary begins to blur, no longer an animal that lives in water, but a biological system optimized for pressure, for temperature, for energy, where each organ does not exist alone but integrates into a single whole, functioning as a complete mechanism, one purpose: to survive within the ocean. And from that foundation, a singular ability begins to reveal itself: the control of breath in a world without air, the capacity to exist almost entirely beneath the surface while still carrying the lungs of a land-born lineage. A paradox begins to take shape. At depths where light no longer reaches, the ocean becomes a realm of near-absolute stillness, where pressure rises with every meter of water like an invisible hand tightening around every pocket of trapped gas, where dissolved oxygen exists yet is so thinly dispersed that it cannot sustain any life dependent on lungs, where everything is shaped for gills, for water flowing through the body, for a biological system entirely foreign to the rhythm of air, and yet within that very space, a lung-bearing creature endures, moves, hunts, lives nearly an entire life beneath that dense weight of water, a paradox that does not vanish, but waits in silence to be understood. For instead of changing the ocean, that body has changed the very way it breathes. Across an evolutionary current stretching tens of millions of years, two great branches emerged, one filtering water through baleen to sustain immense bodies, one armed with teeth to pursue prey through darkness. Yet despite their divergence in feeding, despite the separation into distinct social structures and behaviors, all retained one irreplaceable truth: they are mammals. They require air, and so they must return to the surface again and again, between long descents into the deep, between journeys into regions untouched by light, beneath the growing weight of pressure pressing against the body, a cycle without end, rising, breathing, and vanishing once more into the depths. The body does not resist this rule. It reshapes itself around it, and one of the most visible changes appears upon the crown of the head, where the blowhole has shifted from the forward position of land-dwelling ancestors, moving upward to become a single opening between body and sky, allowing only the smallest portion of the body to break the surface to complete a breath. No need to lift the full mass, no wasted energy, no prolonged exposure to danger, each surfacing lasting only seconds, enough to inhale, enough to exhale, then sinking again. The blowhole ceiling shut through powerful musculature, barring water like a door that cannot be forced open. The transformation does not end with position. It extends deep within, where the pathways of breathing and feeding are completely separated, no longer intersecting as in many land animals, a decisive division that removes the risk of water entering the lungs when the mouth opens underwater, allowing feeding and breathing to coexist without conflict. A mechanism that appears simple, yet stands as a fundamental requirement for any lung-bearing creature to function in a world where all motion unfolds beneath water. The lungs of whales are not merely large, they operate with an efficiency far beyond familiar limits, each breath replacing not a fraction of air as in humans, but nearly the entirety of the air within, reaching 80 to 90%. while in humans the comparable exchange remains at 10 to 15%, a difference not of size but of function, where every second at the surface is used to its fullest, where each breath carries enough oxygen to sustain life for long minutes below. The cycle repeats without end, rising, inhaling deeply, descending again, a rhythm that spans an entire lifetime, with blue whales needing only 10 to 20 minutes before returning to the surface, while sperm whales can disappear for over an hour beneath the ocean, and during that time, the body shifts into another state, the heart rate slows, blood flow is prioritized toward the brain and heart, essential organs kept steady while other systems reduce their energy consumption to the lowest possible level, a redistribution of internal resources as though the entire organism enters a state of conservation, where each molecule of oxygen is used with near-perfect precision. The paradox at the beginning is not erased, it is resolved through ultimate optimization, not by removing the dependence on air, but by accelerating respiration, increasing the efficiency of gas exchange, expanding the storage and distribution of oxygen within blood and muscle, opening access to depths few species can reach, where food is abundant but demands endurance and adaptation far beyond the ordinary, a creature that requires air, yet commands an ocean without it. Evolution does not eliminate limits. It learns to move around them, turning them into part of a survival strategy, so that within only a few seconds of contact with the sky, that body may endure for tens of minutes within a world entirely without air. When the respiratory system reaches such refinement, depth is no longer an absolute barrier, time underwater no longer a rigid constraint. The dark regions where light cannot exist become familiar territory, and as light fades away, another need begins to form, no longer to see with eyes, but to perceive space in an entirely different way, where sound replaces light, where the world is drawn not by images, but by invisible vibrations traveling through water. In the deep layers of the ocean, where sunlight weakens like a memory dissolving into cold water, the world no longer appears through colour, outline, or clear distance. Within the mesopelagic zone, the remaining light is only a dim blue veil, enough to suggest the presence of a sun above, but not enough to reveal the full shape of life. Deeper still, within the bathypelagic, darkness takes near total hold, covering the sea in a dense silence where prey may vanish into murk, slipping like a shadow, turning in an instant, or remaining so still it dissolves into the darkness itself. There, eyes remain, yet vision is no longer a reliable key to read the world. A body that wishes to survive in such a place requires more than sight. It requires another way to know what lies ahead, how deep the water stretches below, where prey moves, whether an obstacle approaches or recedes. When light is no longer enough to construct reality, the ocean opens another doorway, the doorway of sound. Within the branch of toothed whales, including dolphins, sperm whales, orcas, and porpoises, that adaptation has become one of the most refined abilities evolution has ever placed within a marine body. They possess true teeth. They hunt actively, moving through layers of water where prey does not wait to be found, where fish, squid, and countless small creatures appear and disappear among darkness, depth, current, and motion. Yet what makes them remarkable is not merely their jaws, their speed, or their strength. It lies in the fact that they do not wait for light to return. They send signals into the darkness and read the answers the ocean returns. From within nasal passages near the blowhole, toothed whales produce short clicking sounds through a vibrating structure known as the phonic lips. These pulses do not linger like song, nor spread aimlessly like a distant call, but are sharp, rapid, precise, formed to probe the water for objects. Once created, the sound passes through the melon, a mass of fatty tissue in the forehead, where it is focused like light through a lens. Though this is no lens of sight, it is a lens of sound. The beam is directed forward, travelling through water, striking fish, squid, rock, seabed, reef walls, or any object within its path. Then it returns. The echo does not come back empty. It carries information. As the sound waves reflect, the lower jaw receives the subtle vibrations, guiding them to the inner ear, where the brain begins to decode delay, intensity, shape, and variation within the returning signal. A fraction of time reveals distance, a slight shift in intensity suggests size, a distortion in the echo hints at form, direction of movement, even density or internal structure. What is sent is only a click. What returns is an invisible sketch of the world. In darkness, dolphins and toothed whales do not rely on chance to find prey. They sweep through space with sound, detecting small bodies moving through dark or turbid water, distinguishing a swimming creature from a motionless mass, sensing the narrowing distance as the hunt accelerates. As a dolphin closes in, the rhythm of clicks may intensify, faster, denser, as though the map ahead is being redrawn in every moment. Each click is a question sent into the dark. Each echo is an answer returning from the ocean. The world was once perceived through eyes, through light, through the boundary between object and emptiness. But in those depths, light fades, outlines dissolve, and distance becomes uncertain, like a thought dispersing in water. Echolocation replaces that role with a different logic. It does not paint images with light, but constructs awareness through the time it takes for sound to return. The dark becomes a living map, where prey is no longer fully hidden, where obstacles are no longer truly invisible, where the deep sea is not an empty black void, but a structure that can be read through echoes. Sound holds a distinct advantage in water. In many deep, murky, or low-light environments, it travels more effectively than light, reaching distances the eye cannot cross, carrying information back from places that seem consumed by darkness. Through it, toothed whales navigate, hunt, avoid obstacles, and operate within a world where vision alone is no longer sufficient. They do not only possess teeth to hunt, they possess a system to know precisely where to hunt. From a sense, sound becomes a strategy for survival. From a signal, it becomes a way to rebuild reality. Toothed whales are not limited by darkness, for they have turned darkness into a space that can be read. This stands as one of the most profound sensory transformations in the evolutionary history of whales. Not because eyes vanished, but because where sight was no longer enough, sound rose to dominance. They do not see the deep ocean as humans understand vision. They hear its shape, and once that ability is enough to guide and hunt, sound begins to move beyond mere navigation. From clicks that measure distance, the underwater world opens into signatures of identity, distinct whistles, complex songs, connections between individuals and pods, between vast distances and the presence of one another within the immense ocean. In the open ocean, where a living body may drift hundreds of meters from its kind, then thousands, then farther still across tens, even hundreds of kilometers, silence is never truly silent. Light vanishes swiftly as depth increases. Colour is swallowed by water. Form dissolves into shadow, and scent, though it lingers, struggles to become a clear pathway in a space too vast, too restless, too endlessly stirred by currents. In that realm, life cannot rely on sight alone. It must rely on vibration. It must send itself outward through invisible waves, spreading through the water like fine threads that bind together beings separated by darkness, by distance, by depth. For whales and dolphins, the ocean is not merely a vast mass of water, it is an acoustic space, a world where sound can take the place of light, where a call can travel farther than a gaze, where even the faintest signal can cross the immense isolation of the sea. Within that world, the humpback whale emerges as one of the most intricate bearers of sound. The males of this species lift their voices in the breeding grounds of winter, where songs unfold, structured, repeating, evolving, as though the ocean itself were holding a slow, shifting symphony that changes, ever so slightly, with each passing season. In a single breeding region, many males may share the same current version of the song, at times blending into a vast acoustic field, not as chaotic noise, but as a kind of order set within the water. In another branch of the whale family, dolphins, especially the bottlenose, carry a different refinement signature whistles unique to each individual, broadcasting identity and position as though every being bears its own sonic imprint, a trace that declares its presence somewhere in the sea. One species sings as though the ocean were a theatre without walls. Another whistles as though each body carries its own name. From these forms of sound, the underwater world unfolds into layered perception. Clicks are most often linked to toothed whales, where sound is not only sent outward but returns, carrying with it the shape of objects, the distance of prey, the contours of the surrounding world. A sequence of clicks becomes a way to read the darkness, to touch the world without contact, to reconstruct space through echoes of sound. It may appear in social contexts, yet its most defining role remains navigation, hunting, and environmental awareness. Whistles are softer, more clearly communicative, especially in the life of dolphins, where a distinct signal may reveal which individual is present, how far it drifts, how it seeks to be recognized within a constantly shifting group. When mother and calf are separated, when groups encounter one another in the open sea, when distance quietly expands between bodies that once swam side by side, the whistle preserves a fragile connection. And the song of the humpback whale moves differently still, longer, slower, layered, composed of patterned sequences, repeating rhythms, subtle variations, capable of travelling vast distances beneath the water, bound to breeding seasons, to attraction, to recognition, to interactions that science continues to unravel, layer by layer. Clicks read space, whistles name the individual, song opens the depth of society. As these signals weave themselves into daily life, communication ceases to be a single act and becomes a network. An individual carried away by currents can still call. A mother and her young, obscured by murky water, can still find one another. A pod in motion can maintain distance, direction, and mutual awareness through signals that cannot be seen. In a space where a body may vanish after only a few meters of darkness, sound preserves the trace of presence. A whistle is no longer random. A song is no longer an echo. They are structured signals, repeated, recognized, answered, and through that answering, they move beyond their original physiological role to become social behavior. Thus, the role of sound does not rest in a single function. It helps individuals find one another, maintain bonds between mother and offspring, coordinate movement within groups, perceive the environment, detect prey, sense the presence of others. In water, sound travels farther than many other signals, especially at low frequencies, where less energy is lost, allowing certain whale calls to be detected across hundreds of kilometers. This transforms the ocean into a living space connected not by lines, not by borders, but by waves moving from one body to another. When an individual can be heard, it is no longer entirely alone in the vast sea. At the deepest layer of this story, sound is no longer merely a tool of orientation. It becomes a means of sustaining relationships. A click may be perception, a whistle may be identity, a song may be a social structure repeated through breeding seasons, altered through time, shared among bodies that need not see one another to belong to the same living field. This is not language in the human sense, with vocabulary, syntax, and symbols shaped upon land. Yet in the world of whales, it is a system of signals with function, with context, with social roles, with the power to draw distant beings together within an invisible network. When sound can be learned, repeated, and changed, it no longer carries signals alone. It begins to carry patterns of behavior. From calls in the deep, the story opens into a wider layer, where songs, habits, and ways of living may pass between individuals, between groups, across seasons, across years, across long migrations through the ocean. And in that moment, sound ceases to be merely a call. It becomes the collective memory of the sea. Across the wide waters of the Pacific, the Atlantic, and the Indian Ocean, whale populations move along routes so vast that a single lifetime seems no more than a faint trace upon the deep blue map of the planet. And yet, within that immensity, they are not entirely severed from one another. There are migrations that draw groups across intersecting seas, breeding grounds where many individuals gather within a shared acoustic space, distances that are great, yet not so great that the ocean cannot carry signals through the water like a slow, enduring memory. The sea is not only a place where whales breathe, feed, reproduce, and disappear into the depths. It is also a vast network of information, where sound can travel ahead of the body, where a behavior may begin within a small group and gradually spread to others, like a silent ripple across a surface that is never truly still. When individuals can hear one another across distance, life finds a new path through which to pass itself on. Within that network, the humpback whale appears as one of the most remarkable beings of the ocean, not because of its immense size, but because of the complex songs produced primarily by males during the breeding season. These sounds are not scattered calls. They carry repetition, rhythm, structure, extending from minutes into hours, as though within the darkness of the sea, a body weighing tens of tons were building an invisible architecture out of sound. In another branch of the whale lineage, dolphins reveal a different, equally profound capacity, the ability to learn from one another, to recognize sounds, to observe hunting techniques, to adapt to the environment, and then to pass those behaviors through social contact. One species sings to connect, another learns to adapt. Together, they reveal a quiet truth that the intelligence of the ocean lies not only within the brain, but within the ways behavior is preserved among individuals. The song of the humpback whale does not drift as random noise through water. It is organized into small sound units, repeating phrases, larger sequences, arranged with enough stability that multiple individuals within the same region may share nearly identical versions. Yet what makes this phenomenon remarkable is not merely that the song has structure, it is that it changes. Over time, some sounds persist, some fade, some vanish. New elements emerge, as though the song were not a fixed object, but a living form, continuously edited by the memory of the population. At times, change unfolds slowly, season by season. At times, an entire version of the song may be replaced within a span far shorter than the pace of bodily evolution. Genes cannot change so quickly, but sound can. From this point, behavior steps beyond the narrow boundary of instinct. An individual is not born with a complete song inscribed within it as an unchanging imprint. It must listen, it must repeat, it must adjust itself to the songs sung by others around it. A new song may arise in one region, and through contact, through migration, through seasons of meeting and parting, it may spread to other populations until distant individuals begin to carry a shared trace within their voices. Within a single region, many males often sing the same current version, as though the group holds a temporary acoustic language, an invisible agreement sustained not by rules, but by listening. When a behavior not only appears, but is learned, imitated, adjusted, and transmitted, it has moved beyond survival reflex. At first, life seems guided by ancient forces: hunger, fear, reproduction, migration, the need to avoid predators, the search for suitable waters. But in whales, part of existence is no longer entirely bound within inheritance. It depends upon the social environment, upon those who came before, upon the sounds present in the water, upon what is repeated long enough to become familiar. Whales do not merely respond to the ocean, they respond to one another within it. They do not follow currents alone, they follow currents of behavior. When behavior can change across time, across place, shaped by what an individual learns from its community, life begins to take on the form of something larger. In behavioral biology, culture does not require cities, writing, or memory carved into stone. It begins far more simply and far more wondrously a behavior that is learned, passed across individuals, and not entirely dependent on genetics. In whales, songs can be learned and altered. In dolphins, hunting strategies and environmental use may differ between groups. Among populations living in different seas, the same species may carry distinct versions of behavior, like silent dialects of the ocean, From the outside, the sea appears as a uniform blue expanse, yet within it lie subtle differences, acoustic traditions, ways of living that are preserved, habits that are exchanged, identities that emerge and drift with the seasons. This is a deeper layer of evolution. Whales do not adapt only through larger lungs, thicker blubber, deeper dives, or streamlined bodies shaped by water. They adapt through information. A changing song requires no new genetic mutation. A spreading hunting method does not demand thousands of generations. A behavior can move from one individual to another far faster than the slow process of natural selection. The body evolves through blood. Culture evolves through shared memory. When culture emerges, whales are no longer solitary giants drifting through the ocean like living islands. They become connected through shared behavior, shared sound, through what is learned and retained long enough to distinguish one group from another. Whale society thus grows more complex, more structured, more profound, as though beneath the silent surface of the sea exists a world organizing itself through signals that humanity has only just begun to understand. From songs that change with the seasons, a doorway opens into a broader existence, where whales do not merely live beside one another, but learn how to exist together. When sound became a way to perceive space, to call across the dark, to share the location of food, to remain connected within the deep and clouded water, the intelligence of whales and dolphins no longer resided within a single brain. It began to spread between bodies. It lived in calls that were answered, in directions changed at the same moment, in distances held just close enough between individuals moving through the open ocean, the coastal edges, the cold seas, places where prey appeared with the seasons and vanished again like an uncertain breath of the sea. In that world, a solitary individual could hear, could see, could hunt, but a group could do more than that. A group could remember where a school of fish once passed. A group could recognize who was nearby, who had cooperated before, who was a familiar companion across long journeys over grey, cold waters. These bonds might last only through a single hunt, or endure across many migrations, or be held in place by sound, by recognition, by repeated behaviors until they became a form of shared memory. When an individual no longer had to read the ocean alone, society began to emerge as a second sense. In dolphins, that social sense reveals itself clearly in the way groups split and merge, changing without breaking apart, fluid without becoming chaotic. Many dolphin populations live within a fission-fusion structure, where group composition shifts with food availability, relationships between individuals, environmental conditions, or the need to travel. A large group does not need to remain together at all times. It may divide into smaller units to forage, reunite as the waters change, then restructure again like a current finding its path through the invisible terrain of the ocean. Group size may change, membership may change, yet beneath that shifting surface, preferred bonds remain. Certain individuals travelling together more often, responding to one another more quickly, holding a closer distance within the vast sea. This structure offers a quiet advantage. When food is scattered, smaller groups reduce competition among themselves. When protection, movement, or coordination is needed, larger groups bring more information, more eyes, more sound, more ways to respond to a world that never stands still. Society here is not a fixed wall. It is a soft current, able to divide, to merge, to turn, and yet remain itself within constant motion. At another extreme of ocean life stands the orca, the largest member of the dolphin family, one of the apex predators of the sea. If dolphins reveal the flexibility of society, orcas reveal the power of coordination. They live in tightly bonded groups, hunt through strategy, sustain their skills through learning, repetition, and behaviors passed from one individual to another. In Antarctic waters, some orca groups move in parallel to generate powerful waves, pushing water across the ice and forcing seals into the sea. This is not merely strength. It is distance precisely aligned, speed brought into synchrony, the direction of the wave controlled, many bodies turning water itself into a tool. In other hunts, dolphins may gather schools of fish into tighter formations, as though closing an invisible net with their own movement. Some swim along the outer edge, maintaining pressure so the prey cannot scatter. Others wait for a moment of just enough chaos before striking. Roles may shift with the situation, but success does not belong to a single burst of speed. It belongs to alignment. It belongs to the moment when many bodies act as if they share a single rhythm of thought. An individual may be strong, an individual may be fast, but in an environment where prey is always moving, where light shifts through layers of water, where distance stretches until every signal can dissolve before it is fully understood, individual strength is not always enough. When a group coordinates, information is shared through sound and motion. Risk is distributed. The chance of capture increases. Success no longer depends only on size or speed. It depends on synchronization between many individuals. A society can adjust. A society can learn. A society can remember. For this reason, relationships are no longer secondary to life. They become an evolutionary advantage. Through society, dolphins and orcas hunt more effectively, reduce danger when facing large or unpredictable prey, protect the young, relearn successful strategies, and preserve those techniques within the group over time. Among orcas, different populations may hunt in different ways, as if each community carries its own behavioral language. Among dolphins, the flexibility of fission fusion allows them to adapt more quickly to an ocean that never remains the same. From this point, intelligence can no longer be measured within an isolated individual. It exists within relationships. A call can hold many bodies together in the open sea. A movement can begin a hunt. A technique can be repeated, relearned, passed on, until it no longer belongs to the first individual who performed it, but to the entire community that sustains it. The ocean is not only filled with creatures moving through water, the ocean holds society. And once society has formed, a deeper layer begins to emerge beneath hunts and fluid groups' long-term bonds, kinship, the roles of mothers, of calves, of older individuals carrying experience across many seasons of the sea. From momentary coordination, the lives of whales and dolphins move towards something more enduring, the memory of family, preserved across generations. In the open waters of the North Pacific, where resident orca pods move through cold straits, deep inlets, and seasonal currents rich with salmon, ocean society begins to reveal itself not merely as a gathering for the hunt, but as a living structure with memory, with order, with a quiet continuity across generations. Once communication through sound, coordinated hunting, and mutual recognition became the foundation of orca life, a deeper layer emerged beneath every movement. This is no longer simply a hunting group sharing the same waters, no longer a temporary alliance held together by survival alone. It is a family extended through time, where the maternal line becomes the central axis, where the memory of the mother preserves ancient roots, returning salmon seasons, waters that once sustained the pod through years of change. In that world, a pod is not merely a number of individuals crossing the ocean, it is a current of memory in motion. The orca, Orcanus orca, often called the killer whale, is the largest member of the dolphin family and one of the apex predators of the ocean. Yet its power does not reside only in the body, in speed, in teeth, or in the cold precision of coordinated hunting. That power also lies in the way they live together, recognizing one another through distinct calls, repeating hunting strategies learned across many seasons, maintaining bonds so enduring that family becomes more than blood. It becomes a system through which knowledge, skill, and survival are passed from one generation to the next. If coordination shows that orcas know how to act together, family structure shows that they know how to belong to one another. In many resident orca populations, especially in the North Pacific, social life is organized around the matriline, the maternal line, where an older female may travel with her children, her grandchildren, sometimes even her great-grandchildren within a long-lasting group. They forage together, communicate together, move along familiar routes together, as if the ocean were not only a habitat but a map transmitted through bodies, through calls, through habits repeated across years. In these groups, both males and females may maintain lifelong bonds with their mothers. Even adult males do not necessarily leave their maternal group, unlike many other mammals. This creates a rare social structure where generations are not quickly separated, but continue to exist together, to learn together, to carry one another's history. A pod, then, is not a number. It is a place where sound is recognized, where hunting skills are repeated, where migration routes are remembered, where social bonds endure across time. Within that structure, an elder is not a weakened remnant. At times, it is the center. Older female orcas may live many years after they cease reproducing, a rare phenomenon in nature, especially significant in species with complex social lives. When food becomes scarce, these elder females may guide the group, having lived through many seasons of shortage, many shifts of current, many years when the sea was abundant and many when it was not. Moments when survival depended not on immediate strength, but on accumulated experience. They can lead the group to seasonal salmon grounds, adjust travel routes as environmental conditions change, pass on knowledge of where to hunt, when to move, how to avoid danger, and how to respond to changes that never repeat exactly, yet always carry traces of the past. The presence of an older mother or grandmother can increase the survival of her descendants, as if age in the ocean were not merely a mark of time, but a reservoir of experience. From this, the bonds within orca society extend beyond pure biology. Mothers, offspring, and descendants move within a stable structure, but that stability is held not only by blood, but by learned behavior, by observed hunting techniques, by remembered calls, by migration routes repeated until they become a second instinct of the entire group. Each pod may carry its own distinct acoustic patterns, allowing members to recognize one another in an ocean too vast for sight alone to maintain connection. In that space, sound is no longer just a signal. It is a sign of belonging, an invisible thread linking bodies moving apart within dark water, the way a family recognizes itself within immensity. Family thus becomes a system of protection and learning. It allows calves to be sheltered longer, ensures that knowledge of food sources does not vanish with a single season, prevents hunting strategies from needing to be reinvented, preserves migration paths and feeding grounds within the shared memory of the group. When the environment shifts, a young individual may be fast, strong, adaptable, but youth alone cannot always read the distant signs of the sea, cannot always know where fish once gathered, which season once failed, which current once led the pod to life. In those moments, the group relies not only on present strength, but on individuals who have lived through the past. Intelligence does not reside within a single brain. It is distributed across the family. At its deepest level, Orca society emerges as a multi-generational society of the ocean, where elders, adults, and young each contribute to survival, each carrying a different part of the system, a portion of memory, a portion of skill, a portion of the future. They learn, they remember, they pass on experience, they sustain relationships across years, across seasons, across changes that cannot be met by hunting strength alone. The existence of the group is therefore not merely the result of muscle, speed, or instinct. It is the result of family, of matriarchy, of memory carried along the maternal line. From that family structure, intelligence becomes something that can be preserved and shared. From the matriline, experience no longer belongs to a single individual, but becomes the collective asset of the group. From the memory of elders, a pod can endure scarcity more effectively, move with greater precision, respond with greater flexibility to an ever-changing ocean. When family becomes the keeper of survival, the story naturally expands into another layer, where the ability to learn quickly, adapt quickly, and transmit behavior across the entire population begins to shape the intelligence of whales. In the 19th century, when whaling ships under sail still drifted slowly across vast stretches of ocean, when small hunting boats were lowered onto the water to close the distance, with the immense bodies rising to breathe at the surface, a new pressure began to enter the lives of whales. Humans were no longer a distant silhouette upon the sea. The sound of wood striking water, the rhythm of oars, the direction of a vessel's movement, the shadow of a boat approaching from a familiar angle. The harpoon released in a fleeting instant. All of it slowly became a pattern of repeated signals. For whales, danger was no longer only something that came from sharks, from orcas, from hunger, or the harsh demands of migration. Danger began to take on its own sound, its own shape, its own rhythm of approach. And when a threat repeats itself long enough, it leaves behind more than fear. It leaves behind knowledge. Within that shifting world, the sperm whale, a great-toothed whale living in intricate social groups and hunted relentlessly for the valuable oil within its body, became a striking example of how quickly intelligence can rise to meet a new form of risk. These whales did not face a natural predator, but a system of hunting built with tools, strategies, and repetition across countless voyages. Elsewhere in the ocean, the humpback whale, a baleen species known for its flexible feeding behaviours, revealed a different kind of intelligence, not for escaping death, but for discovering more efficient ways to feed. One species learned to evade, another learned to exploit. Together, they suggest that intelligence does not reside quietly within a single brain. As whaling ships drew near, sperm whales were forced to interpret a danger that followed rules. A silhouette upon the surface could foretell the sound of a harpoon cutting through air. An unusual shift in direction could signal an encirclement. A distance closing too quickly could mean death. From such encounters, behavior began to change. Some individuals dived deeper, fled more quickly, avoided approaching vessels, or abandoned predictable routes that once made them easy to reach. Yet what matters is not only the response of a single whale, but the way those responses seem to spread across groups, as though the ocean itself were carrying an invisible map of danger. Analyses of 19th century whaling logs suggest that hunting success declined sharply after an initial period, implying that sperm whales did not simply endure this new pressure. They learned from it, remembered it, linked signals to consequences, and adjusted their behavior far faster than genetic evolution could ever allow. Meanwhile, in the waters of Stellwagen Bank, another story unfolded, slower, quieter, yet no less profound. Humpback whales developed a feeding technique known as lobtail feeding, striking the surface with their tails before or during prey aggregation, sending a pulse across the water that may help concentrate small fish under shifting conditions. This was not a change of bone, not a new organ, not the gift of thousands of generations shaped by selection, but an innovation of behavior. One individual began, others observed. The act was repeated, tested, retained. Over more than 2 decades, the behavior spread through the population in patterns that align more closely with social transmission than with random chance. An invention did not vanish with the individual who first performed it. It remained, carried within the living network. From there, whale intelligence emerges not as a sudden spark, but as a current flowing through bodies, through sound, through movement, through memory. One individual encounters danger, then changes. One discovers a new way to gather prey, then repeats. Others nearby swim within the same space, hear the same sounds, witness the same motions, and gradually reproduce those patterns within their own bodies. When enough individuals learn, behavior is no longer singular. It becomes a form of social knowledge, existing beyond any one body, sustained by connection, by contact, by the prolonged closeness of beings sharing an ocean in flux. That advantage carries profound consequences for survival. The ocean can shift faster than genes. Food sources can move before bodies have time to evolve. Humans can appear as a new pressure within only a few hunting seasons. In such brief intervals, learning becomes the faster path, the gentler path, the more flexible path. It allows whales to avoid dangers not yet written into inheritance, to exploit new prey without reshaping their bodies, to refine hunting through experience rather than waiting across millennia. In a world that never rests, survival does not belong only to the larger, the stronger, or the deeper diving. Survival belongs to those who learn more quickly. And here lies a quiet but immense truth. Whales do not respond through instinct alone. They can remember, learn, adapt, transmit. A danger can become experience. A feeding technique can become tradition. A behavior that begins in one body can become the inheritance of an entire population. When this happens, life no longer rests solely on form, on muscle, on lungs, on blubber, or on the force of a tail. Life begins to rest upon shared memory. From social learning, whales and dolphins approach a subtler threshold, where experience no longer serves only to respond to the environment, but to use the environment itself as an extension of the body. In the shallow waters of Shark Bay, dolphins reveal another quiet capability, where a simple object on the seafloor becomes protection, becomes a tool, becomes a key that opens a safer way to engage with the world. At Shark Bay, in Western Australia, the shallow sea is not merely a still expanse beneath sunlight, but a layered maze, soft and rough at once, where sandy bottoms lie beside jagged rock, where seagrass spreads over small benthic life, where a fish can vanish simply by pressing itself against the seabed or slipping into nearly invisible structures within slightly clouded water. For dolphins, feeding here is not as simple as seeing prey and rushing forward, for their rostrum is sensitive, vulnerable to contact with sharp stone, coarse sand, broken coral, or spined organisms scattered across the bottom. In such an environment, the true challenge is not only to find food, but to find it without paying for it with one's own body. Because not all prey presents itself clearly to sight or sound, especially when it lies low, merges with the substrate, or remains silent within a world already full of noise. It is here that the dolphins of Shark Bay, the Indo-Pacific bottlenose dolphins, Tursiops aduncus, reveal a quiet form of intelligence, not found in loud calls, not in leaps above the surface, but in the subtle adjustment of behavior in response to a precise environmental problem. They are toothed whales, living within complex social networks, capable of recognizing individuals, maintaining relationships, learning from one another, remembering, and transforming experience into feeding strategies suited to their habitat. Yet among the many individuals sharing these waters, only a small group carry something that does not belong to their own bodies: a sponge. This behavior, known as sponging, occurs when a dolphin selects a marine sponge from the seabed, places it over its rostrum, and uses the covered snout to probe, push, dig, or sweep across the bottom. A soft object becomes a buffer between flesh and environment, between sensation and impact, between risk and opportunity. With it, dolphins can access bottom-dwelling fish hidden within sand or substrate, prey that is otherwise difficult to exploit, while reducing the risk of abrasion when navigating rock, sand, coral fragments, or sharp-bodied organisms. The sponge is not food. It emits no signal. It offers no active assistance. Yet when placed correctly, it transforms the efficiency of an entire feeding act. It becomes a glove. It becomes a probe. It becomes a tool. What makes this behavior remarkable is not only that dolphins can use objects, but that not all dolphins do. Sponging appears only within a small portion of the Shark Bay population, concentrated in certain lineages, most often observed among females. Particularly in contexts where mothers require a stable feeding strategy, less dependent on direct competition. If this were a simple instinct shared by the species, it would appear more broadly, more evenly, more predictably, but it does not spread across the population as a basic biological reflex. It follows relationships. It moves through families. It requires time. A calf does not instinctively select the correct sponge, does not immediately know how to hold it upon the rostrum, nor understand where along the seabed reward may lie. It must remain close to its mother for years, observe repeated movements, learn where to descend, how to carry the tool while moving, how to use a protected snout to disturb hidden prey, and how to respond when fish are driven from sand or seagrass. Over time, the behavior ceases to be a skill of one individual and becomes a quiet lineage, passing from mother to offspring, persisting across generations within certain families, like a memory unwritten yet preserved through action. Through sponging, dolphins do more than act as a difficult food source. They open a distinct ecological niche, where competition with dolphins using conventional feeding methods may lessen, where the rostrum remains better protected, where the seabed is no longer merely a dangerous surface but a space that can be read, touched, explored through a soft intermediary layer. Shark Bay itself does not change its form because of dolphins, but the way dolphins enter Shark Bay has changed. A simple object becomes a bridge between mind, body, and place. In that moment, the boundary between body and environment begins to blur, for dolphins do not merely adapt passively to what the seabed offers. They insert between themselves and the world a layer of matter, a temporary extension, yet one of profound consequence. The sponge is not an organ, not a shelter, not prey, yet when used with precision, it reshapes access to the entire seabed. This is intelligence in its quietest form. This is social learning woven into daily motion. This is material culture drifting beneath the surface. And when tools emerge, the ability to engage with space expands not only across geography, but deeper into the subtle dimension of behavior. From a specific seabed in Shark Bay, the story begins to widen, reaching toward greater scales, where whales must do more than use what lies before them. They must remember seasons, currents, routes, magnetic fields, and the long journeys that cross an ocean without a map. Along the western edge of North America, from the cold waters near Alaska, the Bering Sea, and the Arctic fringe, all the way down to the warmer lagoons of Baja California, Mexico, grey whales begin each year one of the longest journeys in the mammalian world. A passage that may stretch close to 10,000 miles round trip, sometimes exceeding 14,000 in certain individuals, crossing waters that shift in colour with the seasons, tracing coastlines that extend like the memory of a continent, moving through oceans where food, temperature, instinct, and life itself weave together into a vast and repeating cycle. This is not a wandering without direction, it is a rhythm, turning again and again through years, through cold seasons, through calving seasons, through generations of calves that grow within the path of their mothers, as though the ocean has inscribed an invisible route deep within their bodies. In the north, during feeding season, grey whales arrive in the nutrient-rich cold waters of Alaska, the Bering and Chukchi seas, and the margins of the Arctic, where the seafloor becomes a vast table, quiet and abundant. They feed by stirring the sediment of the ocean floor, filtering small organisms such as amphipods and other bottom-dwelling invertebrates, gathering energy through the months of cold water, storing it layer by layer for a journey that the body itself must carry. As the breeding season approaches, the direction shifts. Massive bodies leave the feeding grounds and drift southward toward the warmer waters of Baja California, where shallow, sheltered lagoons become places of birth, of nursing, where fragile bodies first learn to swim, to float, to breathe, to endure, before they are strong enough to return to the distant north. At one end of the journey lies energy, at the other, new life. The strangeness lies in this: the journey unfolds without maps, without satellites, without fixed lines upon a surface that is always in motion. Grey whales tend to follow coastal routes that are remarkably consistent, where the contour of continents, currents, water temperature, the scent of the sea, depth, and seasonal change together form a system of signals far greater than any single sense. The repetition of this migration year after year suggests the role of spatial memory, for they must remember not only the feeding grounds of the north, but the breeding waters of the south, the stretches of coast to follow, the waters to avoid, the moments to slow, the moments to continue drifting on. For a calf, the first journey is not merely movement, but a lesson stretched across thousands of kilometers, where the mother passes on the rhythm of swimming, the direction of travel, the resting points, the safe distance. The quiet art of remaining within an ocean too vast to comprehend with sight alone. Some studies suggest that signals tied to Earth's magnetic field may contribute to this orientation, particularly as disturbances linked to solar activity appear to correlate with higher stranding events. Yet this must be seen as one piece within a larger system, not a singular answer to the mystery of migration. The whale's body and memory seem to read many layers of signals at once. As the seasons turn, whales leave the northern feeding grounds with energy stored within their bodies, moving along the Pacific across thousands of kilometers, at times close enough to shore that from land their grey forms can be seen rising, releasing a thin column of breath before slipping beneath the surface again, like slow-moving shadows at the edge of a continent. They arrive in warmer waters, where mothers give birth, where calves build fat reserves, grow stronger, learn to keep rhythm beside their mothers, and after the breeding season, both turn north again, returning to the nutrient-rich feeding grounds. Each year, the ocean witnesses the same migration traced once more, yet never the same journey. For each season carries different currents. Each calf breathes with a different rhythm. Each body must renegotiate with wind, with waves, with hunger, with fatigue, and with distance. Migration, then, is not merely a behavior, but a strategy, a balance between the two greatest needs of life: to feed in order to survive, and to reproduce in order to continue. Cold waters offer food, warm waters offer relative safety, and the distance between them is the cost of not being bound to a single environment. Yet the longer the journey, the more fragile it becomes, for every mile of ocean consumes energy, every coastal route brushes against ships, fishing nets, noise, climate shifts, and the quiet transformations of food supply. The more precise the path, the more it reveals its dependence on the stability of the entire ocean. A creature more than 10 meters long, without maps, without continuous landmarks, without ever seeing the full road ahead, can still traverse continental scales through a convergence of memory, inherited experience, coastlines, currents, environmental signals, and perhaps the Earth's magnetic field. This system does not appear as an object, it unfolds, season by season. When whales move across distances that span thousands of kilometers, they do not belong to a single sea. They connect distant ecosystems into a shared biological rhythm. But the ocean is not only vast, it is deep. From migrations that stretch across the surface of the planet, the story begins to descend, where distance is no longer measured by north or south, but by layers of water falling into darkness. From about 1,000 meters beneath the surface, the ocean no longer resembles the familiar blue waters above. Sunlight has nearly dissolved along the descent, leaving behind a world colder, darker, heavier, where pressure presses upon every surface of the body like a vast hand that never loosens its grip. There, low temperatures slow all motion, darkness strips vision of its dominance, and oxygen, though present in the water, cannot be taken directly by creatures that breathe air. For most mammals, this is not a place to remain. But for the sperm whale, that depth is not merely a boundary of danger, it is where food awaits. The sperm whale, Physeter macrocephalus, the largest toothed whale in existence, is a massive body shaped to breathe air, yet one that turns the deep darkness into a hunting ground. Among whales, it stands as one of the most remarkable divers, descending into layers where the surface becomes a distant memory above. A body that requires air moves into a realm where air cannot reach. It is this paradox that makes the sperm whale an extreme expression of mammalian adaptation. During hunts, sperm whales descend to depths of around 1,000 meters or more, where deep-sea prey dwell in darkness. Some biological records suggest they may exceed 2,000 meters in exceptional dives, passing through a column of water taller than many mountains if inverted from seabed to surface. Feeding dives often last around 45 minutes, sometimes approaching or exceeding an hour, yet every descent must end in return. After darkness comes the surface. After pressure, breath. The whale rises, restores oxygen, recovers for a few moments, then tilts its body downward again, as though its entire life is written in a slow rhythm between air and abyss. To do this, the body cannot rely on strength alone. It must carry within itself a reservoir of oxygen. In the muscles of the sperm whale lies myoglobin, a protein capable of storing oxygen within muscle tissue, allowing fibers to continue working when no new breath enters the lungs. Blood becomes a selective distribution system, prioritizing oxygen for the brain, the heart, and the most essential muscle groups, while less critical tissues reduce activity to conserve what remains. During a dive, the heart rate slows, oxygen consumption falls. The body does not panic at the absence of breath. It contracts into efficiency. In the depths, sperm whales hunt primarily deep-sea squid, including species known for inhabiting regions difficult to reach. But this hunt is not a chase guided by sight. At depths where forms dissolve, where prey passes like shadows through black water, the whale must search through sound, through orientation, through spatial memory, through a physiology refined by evolution for the deep. It emits sequences of clicks, sending sound into darkness, letting it strike objects and return as fragments of an invisible map. In that world, life does not vanish, it simply becomes harder to reach. This descent grants the sperm whale a distinct ecological advantage. It accesses food sources unavailable to most other mammals, reducing competition with predators near the surface, while linking worlds separated by depth, temperature, and light. It feeds below, rises to breathe, moves across layers, and returns matter toward the surface through its body and waste. The sperm whale does not merely inhabit the ocean, it moves through its layers. At this extreme, the sperm whale confronts three fundamental biological limits at once: pressure, lack of oxygen, and near total darkness. Yet it does not overcome the deep through force. It persists through stored oxygen, through a slowed heartbeat, through carefully distributed blood, through muscles rich in myoglobin, through sound in place of sight, through a mode of hunting shaped for a place where eyes are no longer enough. A creature that breathes air, hunting where there is none. From here, the story begins to expand beyond a single body. When whales feed at depth, rise to breathe, move through layers, and release waste near the surface, they do not merely consume the ocean's energy. They begin to move it elsewhere, carrying nutrients from darkness back into brighter waters, where small life can continue to multiply. Whales are not only divers, they become part of the way the ocean sustains itself. The ocean's surface stretches wide like a thin living skin where sunlight still reaches, where beams of light pass through the water and fade with every meter of depth, just enough to sustain a fragile world that quietly determines all life below. Within that space drift organisms almost invisible. Phytoplankton so small that millions could exist within a single drop of water, silently absorbing light, carbon dioxide, and the rare nutrients scattered through the sea to generate biological energy. From there, a chain begins to unfold. Zooplankton feed on phytoplankton, krill consume zooplankton, small fish gather to eat krill, larger fish hunt the smaller ones, seabirds descend, seals pursue, and even the largest creatures on Earth depend upon this delicate foundation. Light is present, nutrients are not always so. In many regions of the ocean, nitrogen and iron become invisible limits, halting life not for lack of light, but for lack of the elements required to begin. And so a void appears, precisely where abundance should have been. From below, a movement begins, slow, deliberate, repeated thousands of times across a lifetime. Immense bodies descending into the depths where prey gathers, where energy accumulates in darkness, and then rising once more to the surface to breathe, carrying within them not only oxygen, but the remains of what has been consumed. When waste is released near the surface, a stream of nutrients is returned upward into the light, a simple act that quietly reverses a natural tendency, where organic matter would otherwise sink and vanish into the deep. This is not a singular moment, but a cycle, a continuous rhythm of descent and ascent, of feeding and release, of depth and surface, a vertical motion, a reversed circulation. What is released bears no shape of life, no glow, no motion, only drifting clouds suspended in water, yet within them lie nitrogen, iron, phosphorus, and the essential elements phytoplankton require to grow. Their form keeps them from sinking quickly, allowing them to linger, to spread through the sunlit layer, where they may be absorbed almost at once. Observations have revealed that waters once poor in nutrients can shift after these releases. Photosynthetic activity rises. phytoplankton multiply as though an unseen field has been fertilized across the ocean's surface. What would be waste in one system becomes, here, a beginning. Nutrients disperse, phytoplankton absorb, light is transformed, carbon dioxide is drawn into living structure, cells divide, expand, and become food for smaller organisms, and from there, the chain begins to move. Zooplankton increase, krill gather, small fish follow, larger fish arrive in their wake, seabirds circle from above, seals hunt, and whales return to the very source they have indirectly sustained. A closed loop forms, not by intention, but by repetition, to feed, to release, to nourish, to feed again. The ocean does not only provide food, it creates more of it through these movements. The role of these immense bodies does not end with the vertical transport of nutrients from the deep to the surface. It extends outward as they migrate across thousands of kilometers, carrying elements from one region to another, linking ecosystems that might otherwise remain separate. Biological productivity is sustained, food webs endure, carbon is held within living biomass and continues to circulate. A creature consumes energy, yet redistributes it on a far greater scale, not only taking, but returning. At the level of the individual, it is merely a repeated sequence, a descent to hunt, an ascent to breathe, a release of what is no longer needed. At the level of the ecosystem, it is a mechanism, a process that pumps nutrients from darkness into light, sustaining the smallest forms of life, and through them, the entire ocean. Not an act of intention, but a function. As long as these bodies continue to move, nutrients are lifted upward, the surface remains nourished, the food chain continues in fragile balance. But when motion ceases, when a great body no longer rises to breathe, another journey begins, slower, deeper, where the entirety of that accumulated mass descends to the seafloor, carrying with it the energy gathered across years, across decades, and transforming the darkness into a place of beginning once more. In depths where sunlight no longer exists, the ocean floor stretches like a realm apart from all familiar cycles of life, where temperatures remain low, where pressure weighs upon every space, where food does not arrive in abundance but falls slowly from above in the form of fine organic particles, one by one, like drifting snow in darkness, accumulating into a sparse energy supply just sufficient to sustain life at its most minimal state. And within that impoverished world, a massive body may suddenly appear, not as a meaningless object, but as an event that reshapes the rhythm of everything around it. When a whale's body ceases its motion within the vast ocean, it does not vanish at once, but begins a slow descent, passing through layers of water, through increasing pressure, until it reaches the deep sea floor, and that moment marks the beginning of a rare phenomenon, an event so uncommon that each occurrence can sustain entire communities for extended periods. A dense source of energy delivered into a place of scarcity, transforming a quiet seabed into a convergence of life. The first arrivals waste no time. Drawn from all directions by chemical traces diffusing through the water, deep-sea sharks, elongated fish with tapering tails, bottom dwellers, crabs, small crustaceans, and countless scavengers, all gathering in the initial phase, where soft tissue, thick layers of fat, and accessible flesh are consumed rapidly, portions of the body disappearing over time, energy transferred directly into those who arrive first, a process that may last for months, even beyond a year, depending on the size of the fallen body. And during that span, a rare food source is exploited almost completely. As the flesh fades, the movement does not end. It changes its rhythm, slower, more intricate. Remaining organic fragments seep into surrounding sediments, transforming previously poor seafloor into an energy-rich zone, attracting smaller organisms, polycate worms threading through the sand, tiny crustaceans, mollusks, and other invertebrates emerging to extract what remains, not only from the surface of the bones, but within the sediment itself, where organic matter spreads beyond its original boundary, creating an area of influence far greater than the body that once fell. When only bones remain, the story does not end, for within that rigid structure lies another reservoir of energy. Lipids stored deep within the bones become the foundation of an entirely different phase, where anaerobic bacteria break down organic compounds, releasing substances such as hydrogen sulfide, enabling chemosynthetic microbial systems to thrive, organisms that do not depend on light but draw energy from chemistry, giving rise to worms, snails, clams, mussels, and a range of specialized species, forming a distinct community that may persist for years, even decades, as long as energy remains within the bones. A body that once moved through the ocean now becomes the center of an ecosystem extended through time, from the first arrivals to opportunistic species to communities sustained by chemistry deep within bone, each stage not replacing the last but layering upon it, forming a continuous chain of life, transforming a point on the seafloor into a temporary oasis, where biodiversity rises sharply above the surrounding emptiness. Death, in this case, does not signify an end. It is a transfer, where a body that once swam across vast oceans, once breathed at the surface, once participated in nutrient cycle above, now carries all of its matter into the depths, providing energy for organisms that will never see light. A movement from above to below, from motion to stillness, from an individual to a community. A living body once lifted nutrients to the surface, now delivers them to the deep. The role does not disappear. It only changes direction. From long migrations, from cycles of nutrient pumping with every dive, to the final descent that becomes the foundation of another ecosystem. That influence extends beyond the lifetime of the body itself, reaching across multiple layers of the ocean, from surface to depth, from light into darkness. And within that continuity emerges a question that no longer belongs to a single species, but to the entire system of which it is a part. In the present age, where the imprint of human presence stretches from the upper atmosphere down to the deepest ocean floor, the ocean is no longer a system apart from human history, but a domain shaped directly by every movement upon the land. After centuries of industrial whaling, from the 18th to the 20th century, certain populations have begun, slowly, to return, like breaths finding their rhythm again after a long interruption, and yet, at the same time, a new layer of pressure emerges, not from a single threat, but from a web of overlapping forces. Water temperatures shift, ocean currents drift from their ancient paths, artificial sound travels far beneath the surface, ships cut across migrations that once followed uninterrupted lines. Nets and fishing gear become invisible snares. After more than 50 million years of evolution, the greatest challenge no longer waits in the dark, nor among ancient predators, but within a world quietly reshaped by human hands. Within this shifting context, whales no longer appear as solitary beings adrift in the vastness, but as intersections where multiple biological currents converge. Baleen whales and toothed whales, though different in how they feed, hunt, and communicate, all take part in a structure far greater than themselves. They move along the upper tiers of the food web, travelling between layers of water, carrying nutrients from the depths to the surface through the slow rhythm of dive and rise. They leave behind bodies that become sources of life for deep-sea ecosystems at the end of their cycles. They connect surface to abyss, nutrients to food webs, carbon to long-term storage, sound to space, memory to the social fabric of their kind. A vast body holds not only biomass, but the quiet capacity to transport and contain carbon across the span of its existence. And so, whales do not merely exist within the ocean. They take part in the way the ocean breathes, circulates, endures. History has already witnessed a time when this balance was broken on a global scale. From the 18th to the 20th century, industrial whaling sharply reduced many great populations, pushing some species toward the edge of disappearance. The turning point came in 1982, when a global decision was set in motion, leading to a halt in commercial whaling from the season of 1985 to 1986, a pause that continues to this day. Some populations have begun to recover, though not all return to what once was. Conservation is not the act of reversing time. It is the quiet effort of preserving enough of a system for it to mend itself. The threats of the present do not gather in a single place, but spread outward like ripples across a surface. Climate change alters the temperature of the water, shifts the paths of ocean currents, and with them the movements of krill, plankton, and small fish, the foundational links of the food web. Underwater noise from vessels interferes with the delicate mechanisms of sound-based navigation and communication, while collisions with ships become a direct cause of death. Plastics and fishing gear do not merely drift. They enter the food chain or become unseen traps suspended in the water. These pressures do not end with a single species. They move through the entire network that binds whales to the ocean itself. From this, a recognition slowly takes form, not as a call to action, but as a natural conclusion drawn from observation. Whales are not only symbols of the ocean. They are part of nutrient flows, part of food webs, part of the sound that travels across vast distances beneath the sea, part of memory carried through generations, part of carbon held within living bodies. To protect whales is not simply to preserve a great creature, but to sustain the microorganisms nourished by the nutrients they circulate, to sustain the deep-sea ecosystems formed from their remains, to sustain communities that learn and remember, to sustain sounds that travel across distance, to sustain migrations that return again and again, like a steady rhythm within the ocean. Within that image, whales become a reflection of something more familiar. Intelligence reveals itself through the capacity to learn and adapt. Society appears in the structures of groups and cooperation. Memory lives within migrations that return with the seasons. Connection emerges through sound and the invisible threads between layers of water. Whales do not merely exist within the ocean, they are shaping it, and the ocean, in turn, remains one of the systems that sustains life across the entire planet.